All right. So for this lesson, we are going to factor trinomials where a is greater than 1. This is a fantastic method that I discovered a few years back that I really like, slide and divide, or the sliding method, however you want to call it. But these are the steps that you're going to use to do it this way. And if you use this, it's going to work. As long as it's factorable, it works every time, makes it nice and neat. So do your best to follow along. The front of these notes is an example step-by-step guide. We are going to start with step 2. I'm not going to give you problems at first where you have to factor out the greatest common factor, but for this method to work, you have to do the greatest common factor first. If you do not do it, if it's a trinomial that you can take out a GCF for and then continue to factor, if you do not do that, this method will not work. So that's why I have all these stars here. So the first step is always going to be to factor out the greatest common factors. However, the first examples that we do are going to be where we don't have a GCF to take out, just so you can get the pattern down. So step 2, after you take out the GCF, if you need to, you won't always have to, you multiply your A and C together, which in this case it's whatever the number out front here is, by this, and then you put it in that spot. All right, so the first step after taking out the GCF, so step 2, is multiply A by C, and then rewrite it as a square as a coefficient of 1. So after you do A times C, you put that answer here, and then just write your x squared or whatever where that coefficient is 1. And then you factor how you normally would, all right, with the double parentheses, where you go here and do your x and your x, which we've done before. And then you put in whatever your answer might be here. At the end of that, you're going to divide your ISA, your y and z, so you can see whatever numbers you come out here when you factor that form. You're going to divide these numbers by whatever your original A was. Okay? And this will make more sense, I think, as we go through it. After you do that, you're going to reduce this fraction. So if you have a calculator that can reduce fractions, you're going to want to do that. I have this one ready to go, so as we go through, I will show you how to do that. After you reduce a fraction, you write the whole number. If they reduce to a whole number, you're good, you're done, and you write out that binomial. But if they are reduced to fraction, once it's reduced to fraction, you're going to put the denominator with the x and the numerator as your new y or z. And again, as we go through this, it'll make sense. So here's an example that goes around with the words of this. So step 1, 2 times 21 gives you that 42. So we write it with a 1 there. Then as you list your factors of 42, of negative 42, so you know 1 and 42, 2, and you keep going that with your calculator, you eventually get to negative 14 and positive 3, which would be your factored forms, because that combines to equal negative 11. Then your next step from here is divide by 2. So you divide each of these by 2, which I showed here. You reduce the fractions then. 14 over 2 reduces to 7. 3 over 2 is already reduced, so it stays the same. And then that final step, since we have a reduced fraction, the 2 goes in front of the x and the 3 remains. So your answer becomes x minus 7, and then 2x plus 3, 2x plus 3. And that is your factored form and using this method. So we're going to go through 3 examples, 2 of them that are pretty straightforward, and then one that's going to be a little bit more, little bit tougher on the next page of your notes. And then I'm going to stop the video and put up a second part where we do have to take the GCF out first and do a couple of those problems. All right, so if we're looking at this using our method, we're going to multiply this times that, so 2 times 2 would be 4. So I'm going to rewrite this as y squared plus 5y plus 4. All right, now I'm going to take my factors of 4. So I'm going to just factor this problem. I'm going to put y, since I'm using y, I'm putting y and y. And then my factors of 4 that have to equal a positive 4. So we have 1 and 4, we have 2 and 2, and that's all we have. We can also use negative 1, negative 4, negative 2, negative 2. But since you notice that this is a positive, and if you've got a good grasp on how to factor a problem when a is 1, then maybe you're taking shortcuts at this point. So you have to figure out what to divide or add up of these, add up to equal positive 5. Well, in this case, 2 plus 2 is 4, 1 plus 4 is 5, so I'm going to use plus 1 plus 4. All right? So now the next step after that, don't think you're done here, because now we have to go back through and we have to divide by our original A. In this case, our original A was a 2. All right, so now I'm going to divide each of these by 2. Now I reduce the fraction. Y in 1/2 is already reduced. I'm taking an extra step here. You might not need to. 4 divided by 2 is going to be 2. So we have y plus 2 with our reduced fractions. And now I can take this 2 and move it out in front of the y. So this becomes 2y plus 1. So I basically take the denominator, put it here, leave the numerator here. And the other one's already done, so we have y plus 2, and that's it. You are factored. If you multiplied this back out using FOIL or the box method, you would get this original problem. All right, so let's try another one over here. So again, we're going to start, first check to see if there's a GCF. We can't take out a greatest common factor because 2 does not go into 5. So I'm going to multiply 2 times 2, which gives me 4. So n squared minus 5n plus 4. Now I'm going to factor out this because it's a coefficient of 1. So n and n. Again, I have a 1 and a 4, 2 and a 2. And now you notice that this is negative, right? So we can't use 2 positives. So, but a negative times a negative is a positive to get us that positive 4. So I'm going to be using 2 negatives. Which ones of these multiply out to give us, or add to give us a negative 5? That would be the negative 1, the negative 4. So I'm just going to put those in there. Negative 1, negative 4. All right, now I'm going to divide these by my original A, which in this case was 2. Reduce the fraction. I'm going to start over here, n minus 2, because 4 divided by 2 equals 2. And if I already know that this is already reduced, I can just put the 2 in front of the n and rewrite it as 2n minus 1. So I'm saving myself a step there rather than writing it out again and then going to here. All right, so that's the basic pattern. Now these were pretty straightforward examples. We're going to do one on the next page, and I'll probably throw one more in there that we can practice just to see if you get the hang of it. All right. Next page of notes, we have this problem right here. Again, this is one without the GCF, so a 9 can't go into a 31 or a 20. So we're going to do our first step. So we have to do 20 times 9. So this is going to be a big problem. But the method is the same. So 20 times 9 gives us 180. So I'm going to rewrite this as x squared minus 31 minus 31x minus, this is a little sloppy, 31x minus 180. All right, now I'm going to list my factors of 180 because I have to figure out what multiplies to equal 180, negative 180, that adds to equal negative 31. Now remember, because it's negative, I'm going to have one positive, one negative, because a negative times a positive equals a negative. So I'm going to go ahead and start listing my factors. So 1 and 180, I'm just going to list them off. I'm not going to worry about signs right now. It's got 180 divided by 2. So we have 2 and 90. 180 divided by 3. So 3 and 60. So we're basically looking for a difference to where we can get to 31. So I have 180 divided by 4. So 4 and 45. 180 divided by 5. 5 and 36. So I notice here that my difference between 5 and 36 is 31. So these are going to be the numbers I'm going to use. But I'll keep going. 180 divided by 6. 6 and 30. 180 divided by 7. Nope. 180 divided by 8. That's not going to be. So I'm just showing you my process of how I get this. 180 divided by 9. 9 and 20. 180 divided by 10. Yep, 10 and 18. There's a lot of factors here. 180 divided by 11. Nope. 180 divided by 12. So I'm getting closer to my divisor, 12 and 15. So anytime my answer is getting close to what I divide in, I'm getting close to being done. 180 divided by 13. Nope, and that's 13, so I'm not even going to try 14. I know it's not going to work. All right, so we know that this is our combination to get to 31. Because remember, one of these has to be a positive, one has to be a negative based on it being a negative 180. So for these to add together, I either have to have a negative 5 plus 36 or a 5 plus a negative 36. Well, in this case, I'm going to have the 36 be the negative number. So when I factor this, I have an x and an x, and it's a positive 5 and a negative 36. So plus 5, negative 36. All right, so that's up to that point. Now I have to divide by my original a. So I'm going to divide this by 20. And now I have to reduce these fractions, okay? So we have to reduce 5 over 20 and 36 over 20. And if you don't have a calculator at home that can do it, here's where you can use this calculator. So I have 5 over 20, and I click on that. It gives me 1/4. So this is going to be x plus 1/4. And then 36 over 20 I have to do too. So again, we're going to use our handy calculator to do that. So 36, oops, that's not right. Go back. 36 over 20. And I want to see what that is. That's 9 over 5. So that would be x minus 9/5. Now that we have that reduced, we take our denominator and put it with the x, leave the numerator. So my final answer for this is going to be 4x plus 1, and then 5x minus 9. So that's like obviously a much more involved problem. You're not going to have too many of those, but just showing you how the process works, if it is factorable, how you can use that method to do that. Part 2 of the notes is going to go over these other problems as far as how to do the problems when you take out the greatest common factor first.